In this lesson, we're going to talk expressions, formulas, and properties of real numbers. By this time, we should know an algebraic expression is an expression that contains at least a variable. So you'll see I've got a number of examples right here, all having variables, additions, subtractions, multiplications, exponents, so on and so forth. If we want to evaluate these, we will typically substitute numbers in for the variables and then use order of operations to solve. And we're viewing those. We always use parentheses first. In other words, we group things inside the symbols and do those operations first. Then you take all your powers, followed by multiplication and division from left to right, and then addition and subtraction also from left to right. So let's go through a few examples. You'll see we've got an expression in terms of P and Q here, where P is equal to 4 and Q is equal to 2. I'll make those substitutions. So we have, in this case, 4 squared minus 3 times the quantity of 4 times 2 plus 9 times the quantity of 4 times 2 cubed. I'll take and do all those exponents first, and in this case I have 16 once again 3 times 4 times 2, and here I'm going to have 9 times 4 times 8. So I once again will look at this and do my multiplications from left to right. In this case I have 12 times 2, which is going to be 24. 9 times 4 is 36, times 8 is going to be 288. And then I just evaluate this, adding and subtracting as I see it from left to right. So 16 minus 24 plus 288 is going to be 280. Similar example, except this time we have a rational expression. This is in terms of x and y. My x value in this case is 4, my y value in this case is 1. So I'll go ahead and just make sure that I substitute. I have 4 plus 1 quantity squared plus 3 over the opposite of 4 squared. Notice I put the negative on the outside, and then that's added to 2 times 1. 4 plus 1 quantity squared is 5 squared plus 3, opposite of 16 plus 2. Now, this division actually works kind of like a couple of sets of parentheses. So I'm going to do everything on top first. I have 25 here plus 3 over negative 14. 25 plus 3, 28 over negative 14, which gives me a negative 2. Little word problem, but basically all this is it's an expression with two values that we're going to substitute in and simplify. So I have A equaling pi times the big R, which is 10 squared, minus the small r, which is 5 squared. So in this case I have pi times 100 minus 25, or 75 pi. So some classifications and properties of real numbers. We'll just go through all the definitions here. Real numbers are the numbers that can be expressed as fractions, terminating and non-terminating decimals. So this is basically all your numbers. So I have a quarter, which we can definitely see as a fraction. 0.59, there's your terminating decimal. Here's your non-terminating decimal, but it repeats. And here is a radical, which in this case is a non-terminating, non-repeating decimal. Right? And then pi, which we know is a non-terminating, non-repeating decimal. A rational number is going to be any number that can be expressed as a fraction, and all terminating and repeating decimals can be expressed as fractions. So here's our terminating decimal, here's our repeating decimal, and we say these can be expressed as fractions. We know 5/7 is a fraction. When I take a look at irrational numbers, those are numbers that neither terminate or repeat. Radicals that are not perfect squares, cube roots, etc., are all non-terminating, non-repeating, and pi, once again, is non-terminating, non-repeating. So then we have three more terms: integers, which are positive and negative counting numbers. Zero is kind of a weird thing. Some publishers call zero a neutral number. It's neither positive or negative, and some publishers include it as a positive number. Whole numbers are positive numbers including zero. And when we talk about positive counting numbers, we talk about 1, 2, 3, no decimals. Natural numbers, positive counting numbers, 1, 2, 3, 4, etc., etc. So if we look at a diagram of how these are all related to each other, the real numbers contain all rational, irrational numbers. So you'll notice Q is given as irrational numbers, I is given as irrational numbers, and within those rational numbers you have your integers, notated as Z, your whole numbers, which are integers, and your natural numbers. So if I'm asked about what classification does negative 2.52 repeating belong to, well, we know it's a repeating decimal, so it's definitely not irrational. We'll mark that off. Since it's a repeating decimal, it could be irrational, and rational is within the set of reals, so this is a definite possibility. It's not a natural number or a whole number because it's not a counting number. So once again, that goes, and it looks like we found B as our answer. So if we take a look at some properties of the real number system, commutative property talks about order and basically says you can add or multiply two numbers in any given order and get the same answer. Associative deals with grouping, and you can change the grouping of any addition and multiplication and get that same number. Identity, for the addition identity property, it says adding 0 to anything gets you the same number, and multiplication identity problem talks about multiplying 1 to any number and getting that number back. Additive inverses, it's basically adding the opposite to get 0. Multiplicative inverse talks about multiplying a reciprocal to get 1. The other commonly used term, closure is not used a whole lot, but distributive basically talks about taking a number, multiplying it by the sum of two numbers, and thus getting the product of that number and those two numbers added together. So in this example, I've given you a starting point, and then we're going to identify the property used moving down. So you'll see that 2 is still in the same place. The numbers have actually changed, so it looks like this 2 has multiplied in. Thus, when we do that, we're talking about a distributive property. You'll notice now all the groupings in the same place. It's just we have changed the order of the 2x and the 2 in this case. So in this case, we're going to talk commutative property. And in this case, you'll notice the parentheses have moved. So we're talking about a change of grouping, so that's the associative. A couple more examples. First of all, let's talk like terms. An expression having the same variables and corresponding exponents is basically what like terms are. When adding or subtracting these, we want to keep the corresponding exponents and the variables the same, and then add or subtract the coefficients. So you'll see if we want to simplify this expression, we take and distribute the 4 to those two terms, distribute the 2 to these two terms, get 12a minus 4b plus 2b plus 6a. Take a look at my like terms. Since I have no exponents, I'm only looking at the variables. So I have the a's, which are like, I add their coefficients out in front, giving me 18a. And the b's are alike, so I add or subtract those coefficients, which gives me negative 2b, and I'm done. Likewise, in a situation like this, it's really no different except we have fractions. So we multiply these guys in, and we end up with a 5d plus c and minus 4c plus 5d. Once again, like terms, d's and c's, no exponents to deal with at this point. So we'll take and just add the coefficients out in front. So I have 5d plus 5d, which gives me 10d. And then I have a positive c minus 4c, which gives me a negative 3c. And I can leave it as is. That's all we've got. Do the problems assigned from lesson 1 prior to coming into class, and then we'll discuss this more if you have any questions. Make sure you fill out your lesson summary on the form provided, and we'll see you tomorrow.